So usually people would just kind of loosely define this as synergy.
Well, I guess that's why a lot of people, in particular with our headphones, like to go with the America approach.
One thing that I've seen countless times over the years, and I'm talking, I've been doing this for 37 years now.
Mm-hmm.
37 years.
Okay.
I started with Bowers and Wilkins in 1985. Been in the industry a long time. I've seen countless times. People don't understand the way amplifiers, we'll start with amplifiers, but the way the system, but let's say amplifiers, interact with the speakers or the load that's presented to them. And, amplifiers can be a variable, a huge variable. And they can sound like one way on one speaker or headphone. They could sound another way on another speaker or headphone. And so we're going to see if we could try to, in layman's terms, explain this interaction and why, or why it occurs and, things like that.
Yeah. So usually people would just kind of loosely define this as synergy, which is an easy enough way to put it, but it's not like a number and you could say, oh, this number matches well with the other number. And that's the issue with the amplifier mating to a headphone. It is kind of difficult to estimate how it'll perform because it depends quite a bit on the design of the amplifier. Because you could look at an amplifier and you can't really tell outwardly how it's designed internally, what kind of circuit topology it has. Maybe you know if it's tube or solid state. But if it has tubes, it doesn't even mean it's tube output. You don't know how the tubes are necessarily being used.
Usually if they're big tubes.
Yeah, well.
Maybe, but it's no guarantee, right?
You never know.
Gives you better odds.
Yeah.
And solid state, of course, there's a handful of commonly used different design methodologies, topologies, and whatnot. And even beyond that, people frequently use different devices in different ways. They intentionally do wonky, weird things sometimes with solid state. It could be to tailor to their specific product. Like sometimes you see manufacturers that make an amplifier exclusively for their headphone. And maybe whatever they did in an amp does benefit their headphone. But people assume that since it makes this headphone sound like magic, it's a good amplifier. And that may not always be the case.
Oh, I kind of see it. I was just thinking about this as like an automotive. It's always automotive references, but
Okay.
People see amplifiers kind of like in a vehicle as like the horsepower rating, right?
Yeah.
That's all you're looking at is peak. Now, all anybody talks is peak.
Right.
This car has 700 horsepower, right?
Mhm.
But most of the time it doesn't, obviously. It's all about that power under the curve and all that.
Yeah.
So amplifiers are kind of the same thing. And where that peak is varies depending on a lot of things, right?
Right.
And just because, some amps, higher impedance, they know that more power or less power, just depends. But that's why you can't just spec one number out.
Yeah, there's no torque specification
Yeah,
on
well.
an amplifier.
Well, even
you don't
beyond
know
that,
where
it's
the
complicated.
curves intersect.
Yeah,
Or,
yeah.
where
You got to see the data. You got to see the curve.
the torque is
And-
kind of like current. I would consider torque would probably be like the size of the power supply. Where it actually could put out physical constant current into a low impedance load. Where if you have a more demanding headphone, is the easiest way to explain it, even though it's not fully encompassing. But more demanding headphones tend to need more current, which means the amp needs a bigger power supply. So you might have that peak horsepower, where at 10,000 RPM, but everywhere else it's useless.
Right.
And you're not listening at 10,000 RPM. You're shifting.
Well, usually you should.
Well, you're only there
that.
for a little
Yeah,
amount of time.
you better hope you ship before that.
Yeah.
99.99.
That stuff starts blowing up.
Yeah.
But yeah, you're only at those peaks for a short period. So, yeah, it's not really a good way to look at it, really.
Yeah, and it's a combination of things like those peaks. Those peaks matter. Especially if you're running into clipping. Let's say you're taking the amp, and at times it isn't powerful enough for what you're driving, whether it be a speaker. I know, a lot of the speakers that we see that we've used in the past tend to be a bigger full size speakers, like 90 dB efficient. And usually, and you play this speaker like that, like in a hotel setting, like we do at shows, on a 100-watt amp, it's not loud enough.
Yeah.
You would think 100 watts with a pair of speakers in a small hotel room would blow the doors off. And we've clipped those 100 watt amps numerous times,
Mhm.
you know, and it's just because of a number of factors. And you wouldn't think that would occur. And the same thing occurs with headphones, you know, and I mean, every amp clips differently, sounds different when it hits that, you know. So
Well, yeah.
you got a lot of variables there so you got to be careful when you're mixing and matching things. You know, you got to be aware of it is what you got to be. And it, like you said, it's synergy.
Well, I think the biggest thing people, for whatever reason, seem to take for granted or ignore is how much power you really need. Because you kind of have two sides of this. There's the more is better. I want as much as I could get. I need 100 watts people. And there's also the folks that they look at the math. They say, oh, well, here's the sensitivity of the headphone. Here's the volume I listen at. That means this is the power I need. Both are a little misleading. Generally speaking, you want more power than you actually truly need to have a little extra overhead, but it is also very difficult to understand how much you're actually loading the device. It's very hard to know at this moment what's the absolute peak that this device will see, since especially on solid state, if they clip, a lot of times it's readily apparent.
Yeah, and that thing is, you know, the only way to really know that is to have an oscilloscope, and most people don't own one of those.
Yeah.
And even if they did, well, you know, they're not. Too bad they don't make like a cheap oscilloscope that you could plug into one of your RC outputs and just like watch things. Maybe someone should come up with that. How hard could it be, right?
Well, there's pretty cost-effective
Yeah, you can
scopes
get
out
stuff
that are
like that.
fast enough for audio use,
Yeah.
but you still have to understand how to use it.
Well, that's true. Yeah. I had got one to set up my turntable. You guys got me one for my birthday or whatever, Christmas. Yeah. And so I was using it to set my turntable, and yeah, you got your typical scope probes, and I'm clipping to a balanced pin on a connector on the end of a connector trying to clip it. You would think I would make an adapter, but that's too much like work. So I'm trying to put these connectors from the cable coming out of the, you know what I mean, just to sit the scope probe just right so I can watch left, right, and align the cartridge to get balance and symmetry on both channels and all that stuff. But anyway, that's the more difficult way to do it, you know. Dr. Fikert came up with a better way. Didn't he just do software that's on a laptop? And
Yeah.
you plug in and there it is.
Oh, yeah.
So, you know, that's the way to go. There are solutions like that where you could load software, I believe. You know, you
Yeah.
just need an adapter box that goes from like USB to some analog converter.
Right. The software-driven scopes are usually kind of sluggish, but
Yeah.
they work.
It'll give you an idea. And
Yeah.
maybe it's enough to capture a peak or I don't know, it might
For
not.
audio, yes,
Yeah.
most likely.
So, I mean, there are solutions to that if you really want to know what's going on with your system. But for most people, I think it's going to be a
little
bit
beyond.
a little bit over the top for that. But, you know, but that's why we have ears. You can listen to this. And then how hard of a load is the actual speaker? And a lot of loads vary with frequency. Like headphones, like planers aren't like that, but dynamics can be like that.
Yeah.
And with speakers, you can go from 2 ohms to 16 ohms, depending on what frequency
Well,
you're
that's
playing
why
through.
they put specs usually like ones that have wild swings. They put like 2 ohm minimum, like 8 ohm nominal or something like that on, because they're
Yeah.
like they can be 2 ohm sometimes. You know?
And then when speakers dip really low, that's when they're drawing a ton of current from the amp. And if the amp doesn't have a big enough power supply, it sounds like an amp running out of steam. And so you run into limitations with the bottom end typically, which is bass drivers are what usually draw most of the juice.
Yeah, I know. Like the most common problem you have that with is like receivers and stuff. You know, they hit like a point where they just go into protection if
Yeah.
trying to draw too much from them.
Yeah, they're rated with this high
Yeah, right.
power rating, but they don't have a big, massive power
Well, the
supply.
problem is that peak number they show you is only one channel driven, and so that's never happening.
Not 7.
Yeah, right. So,
Well, the unfortunate reality is, generally speaking, power at this point is kind of a marketing term. It's loosely defined, and it may actually be an actual number, but how it's rated oftentimes can be misleading very easily. They either rate it at one particular frequency or a particular set of circumstances or for very short duration that isn't really realistic. And so people see this number and they expect, oh, this amplifier is 50 watts. That's way more than I need.
Well,
but it could clip.
Not only that, I noticed that people tend to choose the biggest number they see.
Yeah.
Bigger
is better.
On both sides of the equation.
Oh, yeah.
You know, so they might not realize that, okay, well, this is a 6-watt amp, right? But at what impedance? Like what load are you presenting to it where it gives you that much power? And that's important, because if it's a 6-watt amp at 100 ohms, but it's only 2 watts at 20 ohms or 30 ohms, then what is it? What is it? And then when you change the headphone on that amp to a different headphone, the amp's going to act differently. It's going to sound different. It's not a reference. It's not flat. It's not the same. It doesn't act the same with every headphone or speaker. So, so at that point, well, what is it? how much power is it really doing for you? And and is it accomplishing the task that you're that you bought it for or you're using it for.
We've seen that plenty of times. Somebody says, well, I know it's not the amp that's running out of power because it has 8 watts. And
Yeah.
then you look into it, it has 8 watts at 32 ohms or 18 ohms or some nominal
low
number that they
impedance.
rate it at that's unrealistic. And maybe there's headphones that are that impedance, but you need to understand, oftentimes, if it's rated at 25 ohms or something, at 50 ohms, it's typically half that power.
Well, tube amps vary too a lot. You could have a rating on a tube amp at 100 ohms or something, but then as you go down in impedance, that power drops.
Yeah.
So it could be a tube amp puts out up to let's make up a number 2 watts into 100 ohms. Now you put a 32 ohm headphone on it, it's doing a quarter watt. Where'd all the power go? It was rated for 2.
Well, and on tube amps, sometimes they got multiple taps, 4 ohm, 8 ohm. That adds another bit of complexity to it.
Yeah.
You
So-
always have to look at the specifications.
So to be clear, the same amp, 2 different headphones, completely different specs.
Mm-hmm.
I mean, that's bottom line. That's the layman's way of explaining it. And I mean, it blows your mind to think about that because like I bought this amp because it had this power, but doesn't sound right. Well, yeah, because it doesn't have that power into your headphone or your speaker.
It's quite variable. And
It's
of
tough.
course, in addition to this, some headphones benefit from more power more than others. Some headphones aren't that bothered by being slightly underdriven comparatively. Some headphones don't need or respond as positively to a better dampening factor for an amplifier that has a lower output impedance. Other headphones, more or less particularly planar magnetic designs, really do typically benefit from low output impedance amplifiers. And this is a number that oftentimes is either not particularly accurately represented or not quoted at all in some designs. And for whatever reason, it isn't seemingly like a popular thing for people to look at when they're purchasing it.
The output impedance of the amp,
Yeah.
or even damping factor, which is even trickier to understand.
Right.
Because
really what matters isn't the output impedance of the amp. That's irrelevant in the grand scheme of things. What matters is the output impedance of the amp relative to the impedance of your headphone.
Yeah, you want it to be a lot lower than the headphone impedance.
Right. Typically, that's
better be a
that's
lot
almost
lower.
always the best option.
We're talking many times lower. You know?
So if you have 300 ohm, 600 ohm headphones, you don't need to be too concerned about the output impedance of the amp. And that's actually one of the biggest reasons why headphones like that exist.
Although we've seen like Sennheiser had that amp that they made for one of their headphones,
Yeah,
right?
and it was high output, right?
Yeah, it had a
Very high
200
impedance.
ohm output impedance. It was apparently made to adjust the sound of the headphone, obviously, because when you have that kind of output impedance, it's only made for specific devices. And then we had people who go into the planar realm and plug it in thinking it wasn't a cheap amp. And they're plugging it in and going, how come this sounds so thin? It's like, well, it can't do it.
It was made for a specific headphone.
Yeah. So, it's tricky. This stuff is tricky. The interaction that occurs between systems and headphone is very complicated. And so you tend to be better off working with products that are known givens with what you're trying to do. You know what I mean? People that
Someone
have
has
already
tried it,
so many people are using it with that product that you kind of know it's a simple solution. Dealers are always good with that. They've weeded out, your typical 2-channel stereo dealer.
You hope.
You hope. If they've been around long enough, they know what sells and what works with what, and they weeded out the bad apples, so to speak, or they know how to combine things. So that, no speaker is perfect, no headphone is perfect. Sometimes you're looking for some tone control sort of gear for
For
certain
that's not
stuff.
necessarily a fault. There's legitimate reasons why you'd want that.
Well,
And-
tube amps exist, right?
Yeah.
Yeah, pretty much.
Yeah.
The specifications a lot of time on tube amps aren't vastly superior.
Yeah, the distortion's
But
higher than that.
People really like the way they sound. And so if the end result is good sound, what's the difference how you get there?
Right. Yeah. So it's a tricky road to navigate. And but like I said from the beginning of the video, I've seen this countless times where people don't understand the interaction. They don't understand it. And it's understandable why they don't understand it. It's confusing.
Very
as
complicated.
hell, and it's hard to explain. So anyway, there's pitfalls to audio, and that's one of the things that you got to be careful of, is you want to try to match up the gear with the system with the speaker or the headphone as best as possible, and that's kind of the goal, right? If you're like us, we're developing. We're like cutting edge, if you ask me, for what we're doing with sound. You know what I mean? We're like, we're not after making softer sounding products. We're not trying to hide, or what do you call it? Cover
We're not
or
hiding
mask.
faults. Yeah.
Yeah.
So I guess that is a fair point, because that doesn't necessarily mean that our approach is better or something like that.
No, not at all.
What we're trying to get across is what we do is, I think, quite different than what other companies do.
We push the envelope.
We're trying to make a total package that performs better than anything else. And our headphone being part of that equation, we're assuming you're pairing this headphone with sensible gear. And typically, if you're buying an expensive headphone, you're not going to pair it to like an iPhone dongle or something like that. Not to say you couldn't, but obviously that wouldn't be the expectation when you're making a $5,000 headphone. So we kind of more or less find gear that would work well for this, and then we tune it with and around that sort of gear. And that does have disadvantages for sure, because if you have designs that are a little quirky, like some of these designs that were made specifically for a specific headphone, headphones like ours typically will not perform well at all on those. And so that's why you do see people
A lot of headphones won't perform well on that. Except for the
but
targeted.
it's more exaggerated in certain spaces.
Right.
And
Agreed.
it is why you see people claiming things like our headphones are more amp sensitive.
Yeah, because as the headphone in an amp with a really high output impedance, it can't drive any power current really.
Right.
As soon as you put a lower impedance headphone, even 50 ohms, 32 ohms, even 16, I mean the amp's just dying. It's choking. It can't supply the power, and so that's what it sounds like.
Well, I guess that's why a lot of people, in particular with our headphones, like to go with the America approach and just throw way not like a lot of power,
V8 engine.
just
Yeah,
way too much
sometimes they go
power.
a
I mean,
little
that
overboard,
solves
but-
problems,
Yeah,
right?
yeah.
But
You don't
it
need to
can get
worry about it
dangerous
then.
then.
Well, because at that point you've got them. You got a big power supply.
Right, right.
The thing probably weighs 50 pounds, right?
Mm.
You got the power supply covered. Even if you don't play it at full volume, which you won't because you'll go deaf.
Yeah.
But even if you don't, right? That's probably the why you'll see some people loving to run speaker amps with
Speaker
headphones,
amps, yeah.
with adapters.
You don't run out of power.
I mean, those amps are heavy. They got big power supplies. They're made to run 4 ohm loads, so that they have to be able to put out all kinds of current. So to a speaker amp, a headphone's like a breeze.
Yep.
It's nothing.
But
You know?
we should state, of course, especially to a novice, a speaker amplifier on a headphone has pitfalls, challenges, and it's not recommended unless you really know what you're doing and you assume the risks, because it's comparatively very easy to blow up your headphone.
I think we covered this in one of our older videos.
Yeah.
We probably should rehash that again. In the
I mean, it's
future.
kind of the same problem, but just from a different angle. Because like the amp, like speaker amp designers aren't intending to run like 70,
You'd be
80
unplugging
and that
headphones
too.
into it.
But
Yeah.
they're not. They're usually designed for like 8 ohm speakers.
Yeah.
But now that you're putting like 80 ohm headphones into
Right.
it, and
Could
they're
be
not
an
made
issue.
for
They
that.
could flake out.
So, I mean, most are fine, but it's not.
they're
necessarily
not
true.
made for being connected and disconnecting the load all the time and
Yeah.
stuff like that.
Yeah.
They're made for the manufacturer, designer of a speaker amp is assuming that you have a pair of speakers with speaker wire hooked up all the time, and
Right.
you're not changing them
Yeah, there shouldn't
while
be
the
any
amp's sitting there on.
disconnections,
Right.
You
And
know?
that is a fair point, because I've seen people bring up quite a few times that, well, I have a right hand. I could adjust the volume knob. I'm not a dummy. I know I just don't turn the volume too high. But it goes beyond that. Some amplifier designs could be unstable if the load disappears. So if your connections get removed, if you unplug your headphones or something happens to any of the connections online, it's possible that the amplifier doesn't have enough of a load on it to be stable, and it could actually put out way more power than you intend. It could send out a lot of voltage and blow up a headphone.
Yeah, and that's the problem with having way too much power. I mean, it's fun, it's nice. I know I run 500 watt mono blocks on my 2 channels.
Definitely don't need it.
And I've not blown up a woofer yet.
Right.
But I remember one of our guys here did that. It was years ago.
Mm-hmm.
He was in when none of us were in. He was playing those speakers exuberantly.
Yes.
Yes, and boy, they sounded good right to the point where it stopped playing.
Well, see, there was a different problem. It was a visual problem he ran into because there was 2 pairs of speakers there,
Oh.
a bigger one and your little
I
speakers.
see.
So we thought it was the big ones.
Yeah,
It's like, yeah, they could take it, but he was pushing them.
yeah,
Those little 7-inch drivers so much.
yeah, and that's the issue. With headphones too, it's the same kind of thought process where you got to know the limitations of the driver. Some people don't understand it. At some point, that tiny little speaker is going to give up the ghost if you put too much juice in it. It can't deal with it.
Yeah.
And it could sound clean all the way to the point. It might not distort. It might play 130 dB, right? deafening levels with sounding pretty good, all the way to the point where it stops playing.
Open like a fuse.
Yeah,
It's a trade-off because you want to have enough power so you never experience clipping, but there's no advantage to having way too much power. What you care about is the output impedance and having enough power. Typically, people overshoot it and just go like right to the moon with it and put a 100-watt monoblock on it. That's fine and all, but you do run a risk.
Remember, we mentioned this years ago, but remember when we first started in this biz, we were working with, in the headphone side of things.
Yeah.
We first started working with Alex Cavelli, and he always had some doozies, some sayings, because he was hardcore physicist, and engineering was more or less his hobby, but he was a hardcore, he made things to work forever, he was like a Swiss clockmaker.
He thought through it.
Yeah. Which could be maddening. Yeah. but anyway, remember that one time he says, Joe, you know how hard it is to make an amplifier that'll run a load from 16 ohms to 300 ohms? I'm like, no, Alex, tell me how hard it is.
Yes.
And I mean, obviously that's the deal. That's what you're looking at, right? Because you're dealing with such a variable with headphones. It's crazy. I mean, speakers are pretty common. They know that if they go too low, amps won't even be able to run them. You'll blow fuses. And if they go too high, well, they don't because they can't be efficient. So bottom line is that speakers usually run in a range, but headphones, they're freaking all over the place. I've seen the in-ears run 16 and under, right? I've seen 10 ohms.
Some are super low.
Yeah. What the hell are you plugging that into? That's a low impedance.
I bet you a lot of these amplifier designers would cringe if you told them what you were running.
Yeah.
Right. If you said, "Oh, I'm running 600 ohm on this," I'm running
that's
8
the other
ohm.
thing. Then you got the other. Everything's got multiple connections on it now, so you can plug in multiple headphones, and that's why a lot of amps don't plug in more than one at the same time.
Yeah, right.
Because then you add a whole other variable.
Most aren't made for it.
Yeah.
Then you got two variable loads in there. So
Yeah.
And you're dropping the impedance in half usually with the two of them.
And you have one volume knob for two different devices,
Yeah.
so it's kind of challenging
That's
because if
a
the
real
sensitivity and impedance is totally off, you could have a real problem there.
Yeah. And that's the other factor too when you think about it, like with sensitivity, like higher sensitivity headphones, right? You're barely cracking the volume on a bigger amp, right? It may sound great and you got all kinds of power reserve, but noise becomes an issue now. You got a bigger amp, but now bigger amps usually are a little noisier. Yeah. So you got a high efficiency that doesn't take much power to hear. So the noise doesn't take much power to hear. You hear the noise easier on a high efficiency.
Yeah, the noise floor becomes a big issue.
Yeah, so I mean, there's trade-offs to all this stuff. So it's tough. Like our headphones are different. They're low efficiency, 90 dB, 89 dB. So
solves the noise issue.
Yeah, you don't hear the noise for most amps with our stuff. It's just not.
But you need power.
There. Yeah, but you need power to bring the audio level up to a point where you.
But not
do
too
hear.
much.
Yeah,
but not too much.
And then, of course, inevitably beyond that, manufacturers can be optimistic in their power ratings. And it's understandable because consumers, a lot of times, they look for the bigger power number. If you tell a consumer that this amp is a high price and it has half a watt, a lot of times they go, that doesn't sound like enough, at least if you're driving a demanding load. But you tell them it has 2 watts, it might actually have half. You tell them it's 2 watts, they get all excited, they'll start buying it. And we've seen a bunch of manufacturers do this.
Yeah. Well, not only the manufacturers, the dealers, the ratings.
They inflate the numbers.
Usually when, you look at something like even just if you're ordering from a website or something, it's not going to give you everything. It doesn't have all the specs. You got bullet points there. You're trying to describe the thing. You're trying to be honest about it, and it's going to show power. And that's it's going to be one number. You have no idea where that number lies, what impedance.
But I guess that goes again for automobiles. Same problem. Nobody specs, shows dyno curves. And
nobody looks past the power
peak
figure.
Power.
Yeah,
That's what she said.
Peak power is almost meaningless. Just like peak power in an amplifier doesn't mean anything unless it's rated into your load.
And 0 to 60, 0 to 100 kilometers.
Well, that's you can't really make that up.
Yeah, right. That is kind of telling.
Yeah.
But in the end,
but even then, people now claim that manufacturers have been optimizing so long for 0 to 60 times. That's true.
They do.
You look at the difference now between some cars 0 to 60 and the quarter mile. Some cars look fast, 0 to 60, but it's heavily optimized for that. And then the quarter mile tends to show you it doesn't really have this much power as you think.
Yeah, it's just 62 at bogs.
Well, that's the thing. Corvette
pretty much.
Shifts into 8.
Yeah, Corvette's been doing that for a long time because they know that having a better number is better, obviously.
It sells
so
cars.
What they do is make sure like all new Corvettes hit 60 in first gear, so you don't even need to shift. And that
saves a little
problem.
time to shift.
A bit. Yeah.
So that's one way you can do it. But
avoid the whole double clutch situation.
Yeah,
but it makes it look better than it is.
Yeah, right. True. Well, that's the same with electronics. You really don't know how it's going to sound till you try it. And then even then, you got to have some sort of multiple reference points. You really got to triangulate on what's good if you don't know. If
It's
you've
a good idea,
If you've
yeah.
never tried it, you've got to triangulate. You got to try, if you got a headphone, you got to try a couple different systems on it, a couple different amps to see what's going on with the headphone and the amps, and vice versa. If you got an amp and you got a couple different headphones, you're probably looking for a headphone that fits the amp, right? But the problem with all that whole thing, where if you're actually trying to find one matches the other, is that hopefully the decision's made where the electronics are universal enough where if you change the headphone, it'll still sound good.
Mm-hmm.
You know, you're not picking an amp or electronics just for that one headphone.
Well, you could. But,
Yeah,
yeah,
but that's the thing. Most people do.
Yeah.
Right, because
It's very common.
it's very common, and the two channels the same. Like I said, I've seen it 10,000 times, and I call it a merry-go-round. Everyone's always on the merry-go-round.
well, it's a little different in 2-channel though, because you probably don't have like just stacks of speakers, you know, where you could have
yeah,
20 headphones, no problem.
But you could have an amp that you had for 10, 15 years, and you're
Yeah.
going through speakers, and you can't find a new one that you like. You always like the old one. Why?
Mhm.
Because the amp you picked the amp for that speaker. It ain't working with any other speaker. That's the dilemma.
Well,
see that a
also
lot.
could be just you're used to it because you've been listening to it for 10
Well,
years.
that
too.
helps too, but I think it's because you actually did find, you
Yeah.
took the time at
Well,
that
yeah.
point. And so you could rock through 10 pairs of speakers, right, with that one amp and not like any of them. And you'll go back to the old shoe, but it's really the amp that's causing you the issue, not the speakers.
Mm-hmm.
You know, so you've skipped through, you've done all that work with speakers, but you're not realizing there was an interaction there to begin with. Why? Because the amp always worked before. You know, we talked about this with line conditioners too. I don't want to go into that either. It's the same, but it's the same thing where they bought a line conditioner or something that goes into power line to solve an issue that they had. And then as the system evolves over the years, the issue is gone because you've changed things, right? But you still plug into the same black box, not knowing whether it's helping or hurting. And you always have to second guess these things. We've said it before, and we say again, you always have to second guess the combination.
I think it's more profound than people recognize there, because it's easy if you buy something that works, it solves your problem, to like it. It's easy to be like, wow, this is a great piece. I really like it. It works wonders. It's a common thing people say. And then time goes on, you change something else out in your system, and maybe what this did is no longer necessary. It actually could be a detriment to your system. But it's hard to reevaluate. It's hard for people to say, well, let me yank this out and see, do I still like it? Because it could have just been that this was solving this problem. But in most systems, it doesn't actually help, or it could be worse.
Yeah.
You
And
see
you
that
really-
a lot?
Yep. And usually it's someone who comes and says, hey, you know, something doesn't sound right. Can you help me here? And you go through the system and you look at what they're doing and go, you could usually, a lot of times customers already know. They kind of have a feeling. They have a vague idea of something that's always been bugging them in the back of their mind. You know what I
Yeah.
mean? And they never really addressed it. And usually if you point to the same thing that they had in their back of their mind, it just basically reinforces the fact that, I think I need to deal with that. You know, but anyway, bottom line is that, this can go on. We can go on and on about this.
Yeah.
This is the real ticket is that, you know, if you're trying out something new and it ain't working for you, you may want to go back to the book or somebody who's done this before and say, hey, you know, what am I doing wrong? Is there something I could be doing differently? I think it's something anybody should do, especially if you haven't got the experience level with all the different gear and how it interacts. It's a lot to know, man. Like I said, I've been doing it 37 years and I'm still learning. And I think Paul from PS Audio would say the same thing with his videos. You know, if someone asked him that,
Yeah,
you
actually.
don't stop. You don't stop learning. He just said how old he was. I forgot what he said, 72 or
Something like that.
Yeah, 70 something.
The interesting thing is it seems inevitable that people with a great deal of experience, like Paul, they continue to find out how much these things matter, how you never could really settle on something that's perfection. It seems like it's too easy for humans to say, oh, well, this is great. It's perfect. In my last 2-3 setups, this particular gear worked wonders and it did exactly what I wanted. But it's hard to reevaluate these things continually, but you kind of need to do it. As
all the time.
things around your system change, as parts change in your system, you need to continue to evaluate. Is this cable doing what I thought it did? Does this power regenerator solve the problem I once had? And things like that, and on and on. Because a lot of times you swap something out, you think, oh, it can't be this. This sounds great.
Right.
But you're not checking
Well,
to see if
it
that
worked
sounds
before.
great. You're assuming it sounds great, right?
Yeah.
You know, 5 years ago when you did this comparison head to head between different amps, it sounded great, but is it still as great as you thought it was today?
Sometimes it is.
Yeah.
Sometimes, yeah, that could be a valid output, of course.
Well, I think the three of us are all optimistic in that we always consider things to be progress. We're moving forward.
Mm-hmm.
So not necessarily that newer is better, but that as we move forward in this industry, that we feel like we are progressing toward a common goal, and I mean, that's the way we look at it. And so we're not usually looking in the rearview mirror going, oh, what'd you use 20 years ago?
Mm-hmm.
But anyway, bottom line is that, it's a lot to think about here. We're talking about a very complex subject. And so the best bet is to refer to people who have done it already or experts in the field and see what they got to say. You don't have to listen to them, but see what they got to say. You might learn a few things from them, There's a lot of people out there who have a ton of knowledge. And unfortunately, a lot of the older guys are dying, getting older. They're not talking as much. You don't hear from them. They're retired.
Mm-hmm.
They moved to warmer climates. They're not online.
Yeah.
Well, they don't want to They're like, I got my system. It's done. I don't care.
Right. Yeah. And unfortunately, so the world's losing that reference point. You're losing them. You're starting to lose them. It's kind of like craftsmen, people who used to whittle wood carvings for homes and, moldings and stuff. It's a lost art. These things are gone for the most part. And so audio is the same deal. We're losing a lot of people over the years. And so you got the newer generation taking over online and so on and that. And there's a lot that they don't know about. And so hopefully these videos help. Mm-hmm. That's the idea, is to try to explain to people, at least give them a glimpse or an idea or direction or something to consider. All you got to do is consider the variables.
Mm-hmm.
You don't have to act on them. Just consider them. Always consider them.
Yeah. It's a continual reevaluation.
Could get maddening, though.
It could be real maddening. Yeah. I've learned you got to have a governor.
Yeah.
You got to have an upper ceiling or a limit for the most part. And you don't want to lose it. So anyway, people, thank you very much for watching. Take care of yourselves.